Hi, welcome to Learning Monkey. I am Raghu here. In this class, we will discuss about kth largest element in a given stream of elements. So the explanation here is completely based on the assumption that you already have some basic coding knowledge. If you are not good at basic coding, please visit our website learningmonkey.in, take the course placement training for service-based companies, then come for the competitive coding. Coming to today's class, given an input stream, see here it is not possible to give stream of elements. Assume that it is a stream of elements coming. Means in the internet the elements are coming from the web. So here we are taking the elements in an array, but assume that our elements are coming in a stream. Our task is to find the kth largest element for each element in the stream. If kth largest element not exist, print -1. With example we are going to understand it better. So assume that k is equal to 4, n is equal to 6. It means 6 elements are there. Array of elements are like this: 1 2 3 4 5 6. So the first element we are going to get in the stream is 1. So kth largest element, here k is equal to 4. Fourth largest element, it is not exist, because the number of elements we have is only one element. Then you have to display -1. Similarly, the next stream in the stream, the next element we are going to get is 2. 2 elements are there, so we have to display -1. Next one is 3. 3 elements are there, we have to display -1. Next one is 4. 4 elements are there. What is the fourth largest element in this set of 4 elements? 1. That's why we are going to display 1. Similarly, the next element is 5. What is the fourth largest element in this 5 element? Which is 2. So we have to display 2. 6. Next element is 6. So we have to display 3. This is what we need to display. Take one more example. 10 -1, 2 -1, 4 -1, 9, 2. Next one is 1, 2, 11, 4. This is the output you have to display. But we have to do it in time complexity of Nlogk and space complexity of order of n. So this is very important, Nlogk. How we are going to do this Nlogk, that we have to understand. Coming to the logic part, so listen to this till the end. You are going to understand many things in this example. You are going to understand when we are going to use heap data structure, in which situations heap data structure helps us a lot. These things we are going to understand with this example. So coming to our logic, without using heap we can do this. Take the first element. When you got the first element, place it like this. So because the number of elements are less than k, that's why we are going to display -1. Similarly, take the next element. Input is 1 2, number of elements less than, so display -1. Next one is 1 2 3. Arrange them in ascending order. Whenever you got the new element, arrange them in ascending order. Which sorted order, which sorted example will help you a lot here. If you got the new one, element 4, you have to arrange them in the ascending order. Insertion sort works better here. This is how insertion sort works. Check the back elements and place this 4 at the exact position. So that's why here insertion sort works. So output is 1. The next element is 5. Arrange them in ascending order and display the 4th position from here, which is 2. Next element you got is 6. Arrange them in ascending order and display the 4th position from here, which one is 3. But insertion sort, if you want to arrange them in ascending order, you need to take a time complexity of order of n square. But we need it in a time complexity of order of Nlogk. In order to do that, we go with heap data structure. Why we need heap data structure? Why heap data structure works here? See, in the kth largest element, if you maintain the last k elements, the next element which you got, we need only the k largest elements. Remaining elements are not needed here. That's why heap works here. So you get clarity with the next with the example, with the explanation given using heap. So the second way is using min heap. Here we are using min heap. So the first element you got is 1. Arrange it in a heap. So we are going to construct the heap structure. So that's why it is element is 1. It is in heap. The length. So initially the length of heap is 0. When the first element comes, we have to check the condition len of heap. If it is less than k, push the element to the heap. Here push means it's not push onto the stack. Push into the heap. Means it is going to construct a heap data structure. Min heap data structure. Assuming you already know what min heap data structure means. So next one is, next input is 1, 2. Whenever you got 2, the length of the, what is the length of the heap now? 1. So you have to push 2 onto the heap. After pushing the 2 onto the heap, 1, 2. You have to display -1. This is how heap will be constructed. Next one is, next element is 3. What is the length of the heap now? 2. So push onto the heap. This is how heap will be constructed and output is -1. Next one is, next element is 4. What is the length of the heap? 3. Now push 4 onto the heap. It is going to construct 1, 2, 3, 4 like this. This is what our min heap is. Now the length of the heap is k. So we need to push the elements onto the heap until you got the length of the heap is k. Means we, up to now we maintained k largest elements. The last k elements are enough for us. Remaining elements we can eliminate. We have to keep the last k elements. So now onwards, what's our condition? The next element we got is 5. We have to check this 5 with the element that present on the heap. 5 greater than 1. This is the minimum element present in this entire heap. Means this is a min heap. If this is minimum, means the elements that the children of this one is definitely greater than elements. Children of this 2 is definitely greater than 2. That is what min heap means. So we need to check this 5 with 1. If this 5 is greater than 1, 5 is greater than 1, pop 1 outside, because we don't need 1, because we have to insert this 5 onto the heap. Then we are going to maintain the last k largest elements. So pop 1 and push 5. Now after adjusting the heap, 2, 4, 5, 3. This is what our min heap is. Our minimum element is 2. Fourth largest element is 2. In order to adjust this heap, you need a time of log k. We are doing this for n elements. That's why Nlogk k. So why this is log k? These discussions made in our basic courses when we discuss the data structures. Again we are going to repeat it. So after removing 1 and take 5 here, and the conditions we are going to check is, what's the children of 5? 2 and 3. Which one is minimum? 2 is minimum. So swap 2 here, 5 here. What's the children of 5? 4. Minimum. So swap 4 here, 5 here. In order to do this operation, it will take a time of log k. So that's why our efficiency is log k. Here heap is going to be helpful. Now coming to this, after adjusting we have to display 2. Now the next element is 6. 6 is greater than the element that present here. What is the element that present here? 2. 6 is greater than. So remove 2 and push 5. Push means here heap push. After pushing the element 5 onto the heap, this is how you are going to get 3, 4, 5, 6. So what's the kth largest element? 3 is going to be the kth largest element. So whenever new element comes, do this operation. This is the logic which we are going to follow. But one thing, this is the first example we are going to discuss on a heap. In this example, we are in the examples based on the heap, we are going to use the inbuilt class called Heap Queue. Heap Queue is a class which is already implemented in Python, and it is going to implement a min heap. So in this heap queue class, we are going to have heap push and heap pop functions. Push is going to push the elements and pop is going to pop the topmost element, means minimum element from the heap. So you try to check the documentations of this and then we are going to use this. So if you want to stay on Python, you have to be handy about this heap queue data structure that already available in Python. So coming to the implementation part, by checking the documentation, our suggestion is to try to implement on your own, then check for the solution. So anyhow, coding is available in our website. You can copy it and you can use the code. But so this is the logic. If length of min means, here we are taking min for constructing the heap. If length of min is less than k, heap push element, else check the topmost element with the value which we are going to insert and then pop and push. This is the logic. After coming out of this if statement, display -1 or the topmost element in the heap data structure. Hope you understand this example. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.